Okay, so let's look at a gradient, all right? We have a European terminology where we use the word gradient, and then in America, the word is referred to as a slope. So without me explaining to you what it is, let's see if we can figure out. Now we can give a gradient a mathematical symbol. Let's give it m. Okay. Now to calculate m, we have two methods. We can say, well, delta y over delta x, which is just a Greek symbol for me that means the change in. This translates to the difference in y over the difference in x. So change in y over change in x. Now what exactly does this mean? Well, there's something we need to be familiar with. This is called the slope intercept form. Now depending where you're studying, this will change from slope to gradient, right? Of the slope intercept form. And for this linear equation or linear line, which just means straight line, right? We have y is equal to mx plus b. Now we can sort of see, well, all of a sudden this m is inside of an equation that shows me a straight line. Now what does this m mean? Well, we can see m is going to affect x, right? And x will affect m, depending on which one has a value. This b is an independent variable, which means he's standing alone. So that tells us two things. It tells us, one, that b's coordinate will not change, right? Or b's value in this equation will not change. But m is going to give us some type of change. Now we learned that, or I just told you that we have change in y over the change in x, and then we see, well, m affects a variable. So let's go look at an equation. Let me add one equation. So we can have y is equal to 2x plus 4. This 4 refers to my y-intercept. Let's make a little note there. Okay, so I have a y-intercept. And what this means is, this is just the point at where my function will cross my y-axis. So let's go plot that. So 4's over here. So I'm going to go make a dot. Then we have this m. Well, we know now m is the slope or the gradient, and what this necessarily mean is that for every 2 slots I will go up, I'm going to go 1 right. So let me extend this y-axis. Let me add 2 more points. Let's see. So I'm going to go 1 up, 2 up, and 1 right. And I can make a new point. Then all I do is I simply connect these 2 lines. And there I graphed my function. Okay. I have my function. Y is equal to 2x plus 4. So let's try analyze what the slope is then, or this gradient. Well, I can see if I go 1 box to the right, I need to go 2 boxes up. So to find the next point, I can just follow the same principle. I can go 1 to the right, and I can go 2 boxes up. You see how the line connects? I can do the same thing again. I can go 1 box to the right, and I can go 2 boxes up. So we can see this is how my line changes at some point, right? Now, we know my slope is supposed to be equal to 2, right? In this case. So why do I move 1 to the right? Well, you need to be familiar with something that's known as the rise over run concept. So again, we can just say m is equal to the rise over run. Rise, if I have, let's add some examples. Y is equal to 2x plus 4. Let's say y is equal to negative 2 over 2. No, 2 over 2 is 1. 2 over 4x plus 3. Okay, so let's see. So for the first example, I will have a rise in 2, but I don't have a run. So where can I find my run? Well, I can rewrite 2 as 2 over 1. So we're going to have a rise, which is positive. So I will go up, a rise of 2, and I have a run of 1. So when I run to the right, remember, on my x-axis, let me go back to this axis. On my x-axis, if I move to the right, all these values increase. On my y-axis, if I move up, all these values increases. If I move left on my y-axis, on my x-axis, all my x values decrease. If I move down, all my y values decrease. Okay, so let's go back to our example. So we have a positive rise, so we will go 2 up and 1 right. Right? Let's look at the next one. Well, here we have a slope of negative 2 over 4. Now notice I have a negative 2 as my rise, which means that my rise will be negative 2. So instead of going 2 up, because I see a negative symbol, I will simply go 2 down. And then my run, in this case, is still going to be 4. So I can go 4 to the right. Then we can just simply go plot this. So let's go back to talking about the slope for a second. So let's say I'm given 2 sets of coordinates. Let's say I'm given 2, 1, and I'm given negative 6, negative 4. Now I'm asked to calculate the gradient or the slope. So find m. So how can we find this m now? Well, we've learned earlier that m is equal to y2 over y1, or y2 minus y1, or change in x, change in y, or delta x, delta y. Now how do I actually identify my y2 and y1? Well, we know if we have parentheses, my first value is my x value, my second value is my third value, and just a tip, if there's another one, it would be a z value. So we have x and y. Now notice that these are my first set of coordinates. So I can assign x1, y1. And in this case, these are my second value coordinates. So I can say x2, y2. And now simply we can just substitute the values. So let's go. Negative 2 over, or negative 4 minus negative 1. And for my x values, I have negative 6 minus 2. Simplify. Negative 4 minus 1 is negative 5 over negative 7. And in this case, I can just cancel out my negative symbols. So we have 5 over 7. So now I calculated my slope of 5 over 7. Now let's analyze what the slope means. That means that at my y-intercept, if I can find my y-intercept, from that point, I can go 5 blocks up. So let's do 1, 2, 3, 4, 5. And I need to go 7 slots right. 1, 2, 3, 4, 5, 6, 7. So my slope is going to look something like this. So let's assume we know what our y-intercept is. Now there's obviously a method we can use to solve this, but I'll get to that in another video. And we simply connect the 2 dots and we graphed our function. In another video, I will go over the more advanced linear type of equations that they usually ask, whether it be American curriculum or British curriculum. We'll chat about all of that. But for now, just to recap, so we have our slope-intercept form or gradient-intercept form, which is y is equal to mx plus b. Then we need to calculate our slope, which is the change in y over the change in x. And my